So, well, based on our schedule, we have to finish this exception part. So there are some topics that we still need to cover. So let's begin. I already uploaded this slides also uh, on the Blackboard. So what is an exception? Just as a reminder, in the last lecture we had an introduction to do that. But the thing is, well, when we are writing a code, especially when you are interacting with the users, like we should also handle possible problems. Like when everything is smooth, everything is working well, then your program might work correctly. This is nice. Like your algorithm might be correct. But it doesn't mean that it will run all the time, because in real time, in a professional software, you might face many things that you don't accept. Like maybe you are reading from a file, but the file is missing. Maybe someone deleted that. It can be possible in a multi-user cluster, especially. Or you are accessing an array, but you are trying to get an index. You have an index value which reaches to out of the bounds. Probably you didn't handle in your algorithm a case, so that's why you are leading that. Or you are trying to download the data and then you will process it, but the internet connection is gone. So for those cases, now you need a solution to handle those, because you are, at the end of the day, you are developing a software and selling it to the people. So you are earning money for this, and people are paying money for that. But then they don't want to buy. Probably they will not want to buy a product that works only everything goes smoothly. But whenever you have an internet, any like less than 1 second internet connection problem, and then your problem crashed. So this will be really not good. Or so that's why we need software that can still continue execution, even though there are some problems. This is what we are trying to do with this exception handling. So the program will not crash, will continue to work, and then, but if there's any problem, we need some plan B so that at least the program will be able to do whatever it's supposed to do. So, like, here is one example. Like we are asking the user to provide some data, a data, like H is for the hours, M is for the minutes, S is for the seconds. And then we are checking, going, okay, is it within the limits, like for this set time function? So we get the parameters, but we need to check, okay, is it a reasonable hour? Is that reasonable minute? If so, yeah, we will do that. We will do this setting operation. Otherwise, what should we do? Well, we will see in the following slides later on, but we are throwing an illegal argument exception, which means that like the arguments are illegal. So what is this program is basically saying that whoever uses this function, by the way, there's some mistake in this function. Later on we will see it. But anyway, it is basically saying that okay, if you are doing this, you have to also implement a plan B for these cases, so that this will not run. This will make it a problem. This function will make it a problem that if you provide it invalid numbers. So when we are using this set time function, as you can see here, this is the set time function, and then we are giving some invalid values. What will happen is when we are running it in a try block, since we have invalid values, it will throw this illegal argument exception from here, and then we will catch it here, and then we will print whatever. We will run our plan B, which is in this case just printing a message. So this is just explaining part, so I will skip that. Some common exceptions are array out of bound exception. So let's say you have 10 items in your array, but you are trying to reach the item in index 11. Null pointer exception, your data is actually, object is actually null, it is not initialized, but you are trying to call its function. Class case exception is, well, this will not make sense before we see the inheritance, so let's skip that part. In the following topic, we will see inheritance, then this will make sense. Whatever. IO exception is basically when you are doing an input-output operation. You are either writing to a file or reading from a file. If there's any problem, then it might be an I/O exception. So what is the syntax for it? Well, try, catch, finally. So we basically write 3 code blocks. What is this? Well, try is basically our risky area. Basically, we are saying Java that, okay, this part is like a minefield. At some point, you might get a problem. Like maybe you are reading from a file, you are downloading from a website, you're downloading data from a website. So this is risky. You might have some problems that is out of your control. So it's not about your algorithm, it's not about your code, but it is from some outside problem. So just try to run it. You might achieve it or not. We'll see it later if it is the case. But then if you achieve it, that's good. Then we will jump to this final block and then we will run this part. But if there is a problem, then we will try to catch it. If we have a plan B, we will run it here, and then we will run this final block again. So try block. So let me also try block might be fully executed or not. We don't know. Catch block will run only if there's a problem and we could catch it. Finally, will be always executed block. It will be always executed. So whether there is a problem, it will be executed. Whether there is no problem, it will be still executed. So let's actually do an example for this. So I will go to my part here. Now what I will do is, we have a try block, okay? So this part is our risky area. So our code basically, again, I might have some applications here, like I just set integer a to 5. This is not a risky code, like I just said an assignment. So there's no problem here. But let's say that I'm now maybe reading from a file. Maybe there's no file. Downloading from a file server, download data from a server. Maybe you don't have internet connection. So this part is risky area, okay? So I will try to write this part. For simplicity, of course, I will not try to read from a file we didn't see it yet, or I will just some normally non-risky data. Or actually, let's do it actually. Okay, scanner as is new scanner. Okay, I just changed my mind. Let's say that we want to read data from the user, okay? It was system.in, right? Then we will get user an input, maybe an integer, is the next int, and now we will print it, okay? So this is the, I will just print, this is I. Just to follow my code, I will write here a dummy message that to show that it is being running. So I will say I am in the minefield. Okay, so this part is now I executed it. Now notice that I'm getting an error here. The reason is that I cannot put only try. Like I'm saying that, okay, just try this code, okay? What is your plan B? What should I do then? So what will happen if it fails? I should at least put finally, okay? But not to confuse you, I will also put here my catch part, okay? So I will say that, let's say I'll catch any error. So I'll say that, okay, what will happen if it is, what might be a problem here is, like, my plan B is very ineffective. This is my plan B, just to say that this is my plan B, okay? No, it's not a big problem, but of course what we might do is, okay, let me change my scenario a little bit more. Maybe I I value here. So my plan B is set I to 0. Okay. So first I will run it. We don't need finally block here. Normally it's not mandatory if you have a catch block. So I will delete it now, and I'll say done just to follow my code. Then let's see what we will get. So now it says I'm in the minefield. If I enter a valid number, let's say 5, okay, then it just printed this is 5, and then it printed done. So it didn't say this is my plan B, okay? We just proceeded. So we skipped the catch block. But now I will run it again. But in the minefield, now I will say ABC, okay? I didn't put 5, I just put ABC. Then what happened? My code didn't crash. What happened? But it didn't also say this is ABC, because it cannot, because we are trying to convert it to integer, but ABC cannot be done. Actually, there's an error. So what happened is it says I'm in the minefield. It executed this. It get the data from the user. We created the scanner. Then it get the data from me, but we try to convert it to integer. That's why this part throw an exception. That's why we didn't run this part. All the remaining parts will not be executed. So this try block is partially executed. This part very important. This is partially executed. I just printed this. I did this. When I'm trying to do the third line, it failed. It threw a cache. So I didn't run this part. What happened is I jumped to here. That's why in my output it says this is my plan B. Then it says I is equal to 0, and then it print done. Okay. So this part is important, and then the final part. What is the finally? In the finally case, well, you should basically run it always, whether there is a problem or no problem. This part is basically, so when we run this code, I'm in the minefield, I enter some integer value, it run it always whether there's a problem. So it executed this final block. I will run it again, and when I say ABC, whatever, it also executed again. So why do we have this final block? Well, final block is usually put for your very extremely important data. Like you started to read data from a file. In order to do that, you should first open the file. But let's say that you open the file, you are reading the document, but then at some point it failed, it threw a cache, an exception. Then you didn't have a chance to close it, because we would close it here. Now I'm just, of course, in that one we are not doing it, but anyhow. So I couldn't close it. Normally, if I was able to finish the try block, I would be able to close it, but I couldn't because it throw a cache, an exception. So for those cases, but I cannot leave a file open. So what I should do is, whether I could finish it correctly or not, I need to close it. So I will put this closing function here, this final block. So this final part is like, you get into a house and then you want to just take an item. You will just take an item and then leave, okay? So you get into a house, you see the item, and then you leave. When you leave, you lock the door. You get into a house, you see that there's a problem, there is no electricity, so you go out to call a technician, but you still lock the door. So whether there's electricity or not, you should always lock the door. Of course, in Qatar, you don't need it, mostly. This is a safe country, but anyhow, assuming that in a dangerous area, yes, it is. So in the final block, we put the codes that should be definitely executed. Whether there's a problem or not, we put those in the final block. Do you have any questions so far? All right. So this is just an execution of what I have explained. And this is also, I already explained it. Let me check if I miss anything. No. So why should we use exceptions? Well, try to use them whenever it is really needed. In some cases, it is not. Like, for instance, I want to just I just want to print this value, this object. It's toString value, okay? So I just need to say, print this ref var.toString. Maybe there's a possibility that it is a null value, okay? So you can write it in these two ways. Both are valid actually. In one of them, you can put this in a try block and say that, okay, this is a risk area, maybe it is null. So in those cases, what I will do is I will put it in a try block, and in my catch block, in the null pointer exception, I will say that ref is null. So this is one valid to use it. But it doesn't have to be done with a try block, catch block here. You can also do it with an if statement. Like, you can basically say, okay, if it is null, if it is not null, print it. Otherwise, print this message. So this is a better programming actually instead of that one. So you need to spend this throw exception part for the cases that you really need, okay? So it doesn't have to be always used for any possible problem. Do you have any questions so far? So currently we are having a challenge here because this topic is kind of mixed with inheritance topic that we didn't see it yet. But let me simplify it first, and then once we see inheritance in the following weeks, we can come it back again. In a try block, we can define multiple catch blocks. Like, let's say that if the value is null, I will have another plan. But if I'm trying to, in the same try block, maybe I'm trying to divide by 0, then I need to have another plan. So for different problems, I might have different plans to handle it. That's why that's why in one try block, we can put multiple of them. And then whatever exception is thrown, like if we throw a file not a found exception, this will be executed. If another problem other than file not found exception, if it is an IO exception, then this part will be executed. So this catch block will be skipped, but this one will be run. For multiple catch blocks, remember that, memorize that. Only one of them will be executed. Only. That's so even though you define maybe multiple plans, but only one of them will be executed. The remaining ones will be skipped. Going back to my example, for instance, let's say that I have this problem in which I converted to the integer. Then maybe I would like to do some operation, some division operation for some dummy operation. Okay, I'll just use it for my division operation, and then I'll just print the result. Okay. So for that one, there might be actually multiple problems. First, in order to see that message, actually, what I will do is, this is my simple code that without any try block, okay? So I just ask a user to an input, and then I use it for my division operation. In those cases, if I enter a valid number, it will work correctly. But if I enter an number, I'll get this input mismatch exception. If I give 0, I'll run it again now. Then I will get this arithmetic exception. So I have different problems. So for those cases, what we might do is, maybe I would like to say, okay, if it's an arithmetic exception, okay, my solution would be, maybe I'm just saying that maybe I will be 1. So if it is 0, I will set it to 1. Of course, based on my scenario, then I will just say, okay, I will run only this part, or I will run whatever it is. But if it is input mismatch exception, I need to also write it here. Now this is a different problem. For this case, maybe I just need to write something else. Maybe I will say enter a numerical value. So this is my plan to pass a message. For all other things, I will run this. So what I'm seeing here is now happened. Okay, I have a compile error. Oh yeah, D is not defined here. Okay, fine. So if I enter a number, none of them will be executed. We just run, none of these parts will, none of the catch blocks will be executed. But if I enter 0, then it will print this message. It prints 1. Only this one, but not the others. If I enter ABC, whatever it is, then it says enter a numerical value. So it doesn't run this. It runs only this. Then it skips also this one. Okay? So this part is important. We can define multiple catch blocks, but only one of them will be executed. Okay, this is directly related to inheritance, so I will skip this. Once we talk about the inheritance, we'll come back to this one. And the other one is this try with resources. So what is this? This is take this to again, do not disturb mode. In previously that I said that like if you want to read the data from a file, you need to open it and then you have to close it. There is one shortcut to that. Like you can use a standard try catch block, and then in the finally you can just close it. That is a very reasonable, valid code. Or what you can do is you can do this try with resource command. What is it? In this one, when you write the try, you within a parenthesis, you put this an object that implements this auto closable. For now, since we didn't see interface or so, you can skip you don't know what. We'll not be able to go in detail, but basically as an object that can be auto closable, that has that feature, which is like the scanner object, okay? So instead of putting the scanner here, I'm putting it in between these parentheses, and I'm defining my scanner object as I do previously, like new scanner and some file name. And then what happened is, I'm not closing it here. As you can see, there's no code that says input file.close, because this try with resources will handle that automatically. Even though there's a problem, it will close it. So, if there's no problem, it will still close it. So you don't need to worry about these cases. All right, how many minutes I have? Okay. And when we are dealing with an exceptions, like as you can see, even with this code, normally I would like to just run this part. It's not a very complicated code, but to put all these exceptions, then the code becomes like pretty sophisticated. So in many cases, like adding a try catch might be needed, but it reduces the readability, and you are trying to do many things. So Java actually has two types of exceptions for this case. The first one is checked exceptions, which means that Java forces you to write those functions or use them within a try catch block. So even though, let's say that you want to, in my scanner code, let's also now run, I'll just put another line here. Scanner S1 is equal to new scanner. Then in that one, I'll say just new file. Let me zoom out a little bit. Okay, then I need to imported this file class. Isn't it here? Anyway. Okay. And one more parenthesis. I think I am done now. Is there anything that I'm missing? So this, oh, I was missing one parenthesis. That's why I was getting this error. Anyway. This doesn't make sense. Okay, now I get it. So you can ignore this part, what is file input stream, we will see it later on. But what you are saying is that Java does not allow me to run. I'm getting here an error. And the error is basically saying that, okay, you have to put it in a try catch block. So it is forcing me to write it, okay? I cannot run it otherwise. Because it says, okay, you should really handle this. Like if there's no file, you cannot go and you cannot run it. So you should really write this plan B option. You should definitely write in the plan write this try catch block. But whenever I'm using this, like let me just take this here and write it here again. It is not forcing me to do it. Like, well, it is also risky. Like maybe the user didn't enter some digits, but it is not forcing me to do it. So one of them, the reason is, this is a checked exception, and some of them is an unchecked exception. Like whenever I'm trying to access an array, I don't have to put it in a try block because it is unchecked. This array out of bound exception is an unchecked exception. Because why it is not the case? Well, because if we were forced to put in a try block, our code would be very messy. Like whenever you need to reach and access in an array, you have to put in a try block. So it would be a very complicated code. And the other one is, if you have an array out of bound exception problem, probably there's a bigger problem in your code. Maybe your algorithm is not correct. That's why you are trying to access an index that doesn't exist. So it's better that your program really should fail, and you should really debug that code. That's why it is an unchecked exception. This is also about inheritance, so I will, again, skipping that part. And we can also, in our program, we can also say that, like, we don't need to wait to say that, okay, if we are trying to divide by 0, it will be an exception throw. You can also throw exception in your codes. Say that, okay, if this happens, then throw an exception. Okay, so this is what we can do. And throw is actually a keyword. So when we are defining our function, maybe if some error occurs, then we can say that, okay, if this happens, then throw a new exception. So we throw an exception object there. And then when we are doing it, if we want to throw an exception in our code, we should put this declaration in our method definition, throws exception, so that the people, whoever will use our method, will know that, okay, this function has some risky code, so it might throw an exception. And then when they are using it, now let's say we want to call method 2 here, then the Java will force us to put this method 2 within a try catch block, because it can throw an exception, so we should be handling that. Is there anything that I miss? No. Let's just give one example on our code, then I would like to do that. So let's say that we are running defining a function. So let's say public void some function name, whatever it is, and then maybe it is taking some parameter, and then we would like to say, okay, if a is less than 0, okay, I would like to say, okay, this is not acceptable, so I would like to say, okay, throw an exception for this, okay. So when I do it, now I'm getting another error, as you can see, like this red line. This is because now I'm basically saying that, okay, my code can throw an exception in some cases, so I should warn people who will use that one. So I should put this message throws an exception in its definition. So whenever a code, another function, let's say b, would like to use my code, okay, so it will say that it will call with any function. Like it's not less than 0, as you can see, but I'm still getting an error. The reason is that now if you hit this part, it will oh, this is not a, sorry, this is m. Okay, I'm still getting an error, yeah. It suggests me two options. One of them says add throws declaration, the other one is surround with try and catch. So what does it mean? If I say surround try and catch, basically, yeah, I need to put it in a try catch block because this is risky. What might throw an exception, so I should handle that. This is what we are saying. But what can happen also is, as another option, it also suggests that it says add throws declaration. When we do it, what will happen is basically it says throws an exception also, but we didn't put in a try catch block. So what is happening is what this method B is saying, okay, I will not handle it. I don't know how to handle it. The method who will call me should handle me, so should handle that. So if we have this public, another C function, okay, and then if it calls B, then again, maybe then it will solve the problem, maybe. So this is what we are basically saying. Let me tell it in this way. Let's say that this exception, this is like a bomb, okay, this is like a time bomb. This is our exception. And then this function m throws an exception to our friend, to your friend. Let's say that he's, what was it? Function b. So he either handles that bomb so it will not explode, so try to catch block, or otherwise he also throws it to whoever will call it, to the function, to your friend, so that he either solves it, handles that problem, or calls it or declares then an exception, so that whoever will call that function needs to solve it. But at some point, this error should be handled. Otherwise, your program will fail. Let's do an example for this actually. Now, let me do this and do that. Let's run these functions. So let's create first one main class. All right. And then in this main class, I can call C. That would, actually I would do one thing here also. I would like to throw the exception in all cases. And I would like to say, okay, it is handled. So let's say that when I call the C function now, what will happen is, it will just say it is handled. What is happening is C calls B, B calls M, and M throws an exception. So we come here, B, okay, this throws an exception. What should I do? I don't know. I'll just then, so it couldn't solve it. So that's why it also throws an exception. Then it comes here. Okay, this is now, it is between a try catch block. So now we can attempt to solve it. So now the solution is it is handled so that our program didn't fail. But what would happen if this was also throwing an exception instead of solving that. Now the problem is moved to here. Now we have to solve it here also. And what will happen is now no one solved the problem, so our program crashed. So at some point, if you reach your main method and still even main method does not solve it, then your program will crash. But if any of them will handle that, then you are good. All right. Let me also explain this part and then I will stop. So in Java, can we throw any object? Like, because in this one, as you can see, I'm throwing an exception, an object. This is an object actually, exception object. So can I throw anything? Maybe like, can I throw a string class, string object? No, you cannot. So can I throw some numbers maybe? No, you cannot. So we can only and only throw an exception object. There are multiple types of exception objects, but again, eventually it should be an exception object. Well, in C++, yeah, you can throw anything like in this part, but in Java, yeah, you have to throw an exception, an exception object. And in your code, you can also throw multiple exceptions. Maybe like you didn't solve any of it, so you say, okay, this is IO exception, this is always exists exception, or whatever. So for each of them, you put a comma and then you can list it. You might say, okay, why don't we solve it? Well, because maybe in a program case, maybe you shouldn't. Like, as an example, let's say that you are working in an e-commerce platform, and then you are working on this set price function, okay? And then, what if the price is set less than 0, okay? So this is an error, or maybe you can solve it, but what you can do, what will you solve it? Like, if the price is less than 0, what is your solution? Is the price of the item should be 0 then, 5, 10? I don't know. So the thing is, I don't know how to solve this problem. Whoever called me and gave me this invalid number should handle this. That's why I'm saying that, okay, if the price is less than 0, throw an exception. So it's a big problem. I don't want to solve it because now in the system they are putting some negative numbers to the prices. So it should be solved definitely. That's why I'm throwing an exception. Like, if this is not solved, the program will crash. But the thing is, I don't know how to solve it. That's why I don't put it in a try-catch block or so. I'm not attempting to solve it. But whoever calls me should solve this problem. This is why we can use this declaration. We can add this throws exception cases. All right.